Welcome to another episode of Terry's Notes, and today I'm going to be looking at the January 2015 paper, question 3. Alright, the first part says state two natural sources of hydrocarbons. So we can get hydrocarbons from natural gas. We can also get it from petroleum or crude oil. Alright, and we can also get it from peat. Right, so all we need is two. So you just need to remember natural gas is one natural source of hydrocarbons, as well as petroleum or crude oil. Right, those two would suffice. Now, part B, the fractional distillation of crude oil produces several fractions, each containing a range of compounds with varying numbers of carbon atoms. Alright, so three of these fractions are labeled 1 to 3 in this table below. So this is fraction 1, fraction 2, and fraction 3. And the number of carbon atoms, so C1 carbon, 1 carbon to 4 carbon, is what we call in fraction 1. If we have between 12 and 18 carbon atoms, that is fraction 2. And if we have between 20 and 40 carbon atoms, we are calling it fraction 3. So the question asks to identify one of these numbered fractions. Alright, so in the case of, let's say if we choose fraction, let me just write it on the side here, right? We could have said identify 1. So we could choose, if we choose 1, right, which is C1 to C4, that is called refinery gas. So this is refinery gas. C12 to C18, right? That can be kerosene, and C20 to C40, that is, let's say, bitumen. Right, so we just need to choose one of the fractions. So this is fraction 1, this is fraction 2, and this is fraction 3. And then the command said state one use of fraction 3. So if fraction 3 is bitumen, then we know that we use bitumen to pave the road. So we basically use it for road surfacing. Alright. Some things I should also mention here. The same one where we have kerosene, right? We can also have diesel inside here as well. That is DIESEL. We can also have paraffin oil. Right? Okay, so let's move to the next one. So we have compound W and has a characteristic odor of pears. Now once you see an organic, at least at your level, when you see something has a characteristic smell, right, in the case of pears, without you reading anything further, I can tell you that this compound has to be an ester. So they said identify the homologous series to which this belongs to, and it belongs to the ester group. right? And this here is a functional group present in an ester, right? And before I even move on to anything else, right? Now, ester is usually made up of an acid and an alcohol. So before I move to anything else, I can actually tell you what the acid is and what the alcohol is. Alright, so this is the acid, and the alcohol will be this, right? So these two compounds, when they react, they give me the compound W. Now let's see what they want. Oh, okay, so they said write the fully displayed structural formula of the two molecules that are produced when W is hydrolyzed with dilute hydrochloric acid, and state the name of one of these structures, right? So like I said, I kind of gave you the answer before, really. So the two structures, we are doing acid hydrolysis. So what we're going to end up with is this H, and then we're going to have 1, 2, 3. Right, so right, so this structure A here, they said they want the which one we have to choose. We have to choose either A or B and name it, right? So if we choose the first one here, structure A, we have 2 carbon atoms, so therefore this is just ethanoic acid, right? And this alcohol, there's an alcohol here, and we have 1, 2, 3 carbon atoms, right? So this is really propan 1 all, right? Now they said glucose is a monosaccharide that can be represented by this here, right? At your level, you just use symbols because the actual structure of glucose is very different to this, right? All we are concerned about is what happens to the functional group, the OH group. Now state the name of the polymer of glucose, and using 3 glucose units, draw a partial structure of this named polymer. Alright, so the monomer is glucose, and it's a monosaccharide. So when glucose polymerizes, we end up with starch. So the name of the polymer is starch, and let us draw a partial structure. So we have alright, let me just shade this here so you don't confuse. So we have this, right? This represents this part here, this here, right? And this is an oxygen atom here. This is also an oxygen atom, right? Just don't get confused. Alright, so a student is asked to distinguish between a sample of glucose and a sample of its polymer. So we have right, he adds water to separate portions of glucose and its polymer and stirs. State the expected observation. Well, we add in glucose to water, so we know that state the expected observation. So glucose dissolves to form a clear solution. Right? In the case of the polymer, which is starch, starch is insoluble. Right? So what you end up with is a cloudy suspension. Right? Because starch doesn't dissolve in water. So what you get is a cloudy suspension. Okay? Alright, so let's do the last part. Alright, so you have the monomer shown below undergoes condensation polymerization. Name the type of polymer formed and give one use of this polymer. Alright, now this is taken straight from the syllabus really. You should review my video on polymers. So we have this monomer here. We have two functional groups present. We have the amine. We have the amine group, and on this side we have the carboxylic acid group. Carboxylic acid group. Right? So name the type of polymer formed. Basically what you're gonna get is a polyamide, right? And well, in this question it didn't ask you to draw it, but I can show you what it will look like. Let's draw the box initially, and then we're gonna have C double bond O, and we're gonna have NH box again, right? And we're gonna have C double bond O and H, right? This is explained in that video that I'm speaking about, so just take a look at the polymerization video and what they want a use of this polyamide. We can say we use it to, we can make ropes. We use it in textiles or clothing, right? To make paint brushes, right? So any example we can give for the polyamide will be fine. Okay.